Bridge failures rarely stem from a single cause. They occur when structural limits are exceeded, maintenance lapses, or environmental forces surpass design assumptions. The causes are identifiable and preventable. 1. Extreme weather. High winds, flooding, storm surges, and lightning increase dynamic loads. Wind resonance amplifies structural oscillation. Water accumulation adds weight and accelerates fatigue. Climate volatility heightens risk, especially for older bridges built to outdated standards. Prevention. Upgrade wind and flood resistance. Improve drainage systems. Install real-time structural monitoring. Reassess climate load assumptions. 2. Structural overloading. Bridges are designed for fixed load limits. Repeated overweight traffic weakens beams, joints, and reinforcement. Cumulative stress erodes safety margins, particularly where enforcement is weak. Prevention. Enforce weight limits strictly. Deploy weigh-in-motion systems. Monitor load distribution. Conduct regular fatigue testing. 3. Seismic activity. Earthquakes impose sudden lateral and vertical forces. Older bridges often lack seismic reinforcements such as dampers, flexible joints, and strengthened anchorage. Resonance can push stress beyond tolerance. Prevention. Retrofit vulnerable bridges. Install dampers and base isolation systems. Apply modern seismic codes. Perform continuous integrity assessments. 4. Maritime and external impacts. Bridge piers are exposed to vessel collisions. Larger ships and complex navigation increase impact risk. A single strike can critically damage load-bearing supports. Prevention. Reinforce pier protection. Enhance vessel tracking and navigation control. Improve channel design and traffic regulation. Use impact-resistant structural designs. 5. Corrosion and material degradation. Corrosion and concrete deterioration progressively weaken internal reinforcement. Water, temperature shifts, and chemical exposure accelerate decay. Deferred maintenance allows hidden damage to accumulate until failure becomes sudden. Prevention. Conduct routine ultrasonic and drone inspections. Use corrosion-resistant materials and coatings. Secure consistent maintenance funding. Detect cracks and rust early. Core risk factors. Aging infrastructure. Infrequent inspections. Outdated standards. Budget limitations. Weak regulatory enforcement. Bridge collapse is rarely without warning. Vibration anomalies, cracking, sagging, corrosion, and abnormal load stress typically precede failure. Strategic priorities. Continuous structural health monitoring. Data-driven maintenance planning. Strict operational enforcement. Climate-adaptive engineering standards. Sustained infrastructure investment. Bridge resilience requires constant oversight, reinforcement, and regulation. Ignoring early warning signs significantly increases the risk of catastrophic failure. Preventing bridge collapses requires a shift in engineering and maintenance. Designs must account for extreme weather, heavier loads, and future climate conditions. Bridges should be built with resilience in mind, not just historical standards. Continuous structural health monitoring is essential. Embedded sensors can detect stress, vibration, corrosion, and load anomalies before failure occurs. Predictive maintenance replaces reactive repair. Aging bridges need retrofitting. Seismic dampers, reinforced supports, corrosion-resistant materials, and impact protection for piers. High-performance concrete and advanced steel extend lifespan and reduce deterioration. Strict load management is critical. Automated weigh-in-motion systems and traffic monitoring prevent overloading, while navigation and pier protection reduce maritime collision risk. Modern inspections using drones, ultrasonic scanning, and digital twins detect early damage invisible to the eye. Coupled with sustained funding and mandatory maintenance, these measures ensure bridges remain safe under growing environmental and operational stresses. Bridge safety is no longer passive. It requires anticipation, monitoring, and proactive reinforcement.